Thanks so much for having me. It's really fun to be here and meet new people and meet some people I've met before. So I'm going to talk to you about one strand of my work. I also work on some other stuff related to healthcare, for example, but I'm not going to talk about that today. I'm going to talk about the part of my work that intersects more with the humanities. So I'm going to talk to you about two projects, storytelling and poetry. And I work in a field called cultural analytics, and not everyone knows about this subfield, so I just want to introduce it a little bit. Cultural analytics is the computational study of cultural objects, processes, and agents. That could be like books, movies, games, media. And traditional unsupervised NLP methods like topic modeling, word embeddings, lexicon-based methods, these continue to be really important methods within the field of cultural analytics. But of course, like everywhere else, large language models and vision models are unlocking new ways for us to study human culture and also creating new complications for human culture. I really like this quote from Alison Gopnik from UC Berkeley. She was speaking about the upheaval to the field of NLP brought by large language models. And she said that large language models are the newest version of cultural technologies like language, writing, libraries, internet search, and Wikipedia. And to me, this means that we can study these models in the same ways that we study other cultural technologies and human curations. Um, and those are human questions, questions that are studied in the humanities. And I like to pose two ways to think about culture and language models. So first and more prominently, there's a downstream view. This would be the more familiar view for NLP or an industry, where we have a big model and then we're going to use that model for tasks. And a lot of NLP is structured around these kind of downstream tasks. Thinking about questions for human culture, we can also model those questions as downstream tasks. So for example, that might be asking a model to classify a poem's form. But there's also all this stuff upstream of the model that's not always studied. There are data sets, curation, text processing decisions, and the human curators and authors behind those decisions. Upstream research uses the same language model that we were using for the downstream questions, perhaps, but not necessarily for downstream tasks, but to answer questions about the source data set and its authors. For example, like where does the training data for large language models come from? What's in it? But also, how can we build good evaluation data sets for humanist research questions? How can we use these models as tools to explore other data sets of interest? For the humanities, that might mean searching those data sets for published poems. So going through our pre-training data and looking for the cultural data that we're interested in, perhaps searching for biases in the distribution of those poems. And it's important to keep in mind that most NLP models and methods weren't designed for these upstream and humanities-based tasks. They're designed for those downstream and industry type tasks. So we sometimes need to think carefully about our methods and the stability of our measurements. In today's talk, I'll present two first steps toward using large language models for humanities and cultural analytics. Before we can draw big conclusions, we need to test models for their capabilities and build tools. And both of the works that I'll present are data-centered works, but they'll one come from the downstream and one from the upstream direction. So I'll start with a study of storytelling on the internet. In this study, I brought together and led this wonderful interdisciplinary team to study online storytelling across diverse communities. Our team included computer scientists, a law and econ researcher, and a literary scholar. And in particular, in a lot of my cultural analytics work, I'm really interested in storytelling and narrative and computational approaches to narratives. Storytelling on the internet is interesting for a lot of different reasons, I think. It's important as a rhetorical strategy, as a form of self-disclosure, as a sense-making strategy, and coming from our more NLP perspective, it's important as pre-training data for large models. For pre-training data, we gather up huge amounts of internet data, and that internet data, a lot of it is storytelling. On the internet, storytelling is scattered across communities. We can't just say like, okay, all the storytelling on the internet happens here, if only. For example, maybe we have some research question about storytelling that happens in online healthcare communities. And maybe we're interested in how that storytelling is happening across different healthcare communities. Identifying that storytelling, and in particular, identifying storytelling spans like what I'm showing here, could help us answer questions maybe about the sense-making practices that users engage in and how storytelling helps them through their healthcare journey. We could also try to identify common patterns in their stories, sequences of events in their stories. There's a lot we could do given storytelling spans, but that all first requires building and evaluating a story detection system. But detecting stories across communities faces some big challenges. Getting those spans is hard. First, like I was just saying, stories and non-stories are mixed together across topics and within individual texts. So like I was showing here, we can have a text where just part of that text is story and the pieces outside of it, maybe we wouldn't consider story. So they're mixed together. Second, defining stories, like what even is a story? What am I talking about right now when I say the word story? It's very difficult. There's an entire literary field called narratology concerned with the theory of narratives. And we're not going to solve all of those problems today, but I'll offer one possible answer. And another challenge is that existing story data sets didn't meet our requirements. So going into this project, we thought, great, we want to find those storytelling spans. We'll use one of the many story data sets that are available within natural language processing to train a classifier. We'll get those spans and we can move on to the next part of our project. Wrong. There are a lot of story data sets, but those data sets are not designed in such a way that you can use them for the prediction of storytelling spans. So to address these challenges, our answer was to create this framework. We called it the Story Seeker Framework, in which we formalize the task of story detection and the task of story span detection. That's a task that has only been worked on maybe once or twice before and not formally like this. We link story detection to event detection for the first time, and we released the first expert annotated dataset, codebook, and models for story detection across diverse online communities. I'll now go through in detail how do we achieve these goals? How do we get to this point? So the first step is to build a story detection data set. Like I said, we didn't have a data set that met our requirements, so now we're going to have to make our own. This was the hardest part of the project by far. Annotation is hard. So we went through many iterations of open coding discussions and alignment between the annotators. Again, we had an interdisciplinary team, and every author on this paper worked independently and then would come together. We would annotate data, then come together to compare our labels, and then design a code book or an annotation book containing a description of storytelling that fit our context of diverse online communities and our research goal of detecting and measuring those storytelling spans. We were inspired by, but deviated from some important prior work, in particular, this paper on narrative theory for computational narrative understanding by Andrew Piper, one of our co-authors on this project, and then this paper on literary event detection by Matthew Sims and David Baman. We had a lot of difficult decisions that we were faced with. There are stories, for example, that are told kind of in a hypothetical sense, like what might happen. There are stories told in the present tense. There's a lot of things going on with verbs and tense that we had to sit and think about very hard and decide together whether we wanted to include those as stories or non-stories. To summarize all of that, and to summarize our lengthy code book, the operationalization that we hit upon is that a story for us describes a sequence of events involving one or more people. Notably, as long as a text meets those requirements, as long or as short as that span may be, regardless of whether, it's as short as one less than a sentence or as long as like an entire document, we will label it as a storytelling span. And to maybe like preemptively defend ourselves a little bit, this is not really a definition of storytelling. I'm not going to argue right now that this is the definition of what a story is or that's the best definition. I'm not going to say it's a definition. It's a guide for us to identify those storytelling spans. The full codebook is available on our GitHub repo for this project. There's a lot more detail in there. Like, what do we mean by people? That ends up being surprisingly complicated. We don't have like a list of entities that we're looking for. We have some listed to explicitly include, like, again, aliens, animals. We don't list those out explicitly. Ultimately, there's some subjective judgment here for the annotator because of this fuzzy boundary between, like, when does it become too many entities? Same questions around, like, what do we mean by events? What do we mean by sequences of events? All in the code book. We can talk more about it. But if you're curious or if you would like to reuse our code book, it's all on our the GitHub repo. Here's an example of what the task ended up looking like. So in our workflow, we annotated event spans first, and then we annotated story spans. And this strong emphasis on events while annotating story spans is novel to my knowledge and adds consistency to the annotation of this very diverse set of text. So this is a really hard annotation task, and adding in the event annotations helped us ground ourselves a little bit. So the underlined parts here are parts that we annotated as events, and then the blue highlight is the storytelling span. And this is a great example of a very boring story. It's not maybe a good story, it's not an exciting story, but it meets our definition of events happening in sequence and a particular person being involved in those events. The final data set includes 502 texts with event and story spans sampled randomly from the larger data set of Reddit posts and comments. And our inter-annotator agreement for both the event spans and the storytelling spans was within the traditional substantial range measured via Cohen's kappa. And ultimately, 47% of the texts included story spans according to our final consensus labels. So after I and one of my co-authors, Joel, we independently annotated every single one of those 500 texts. And then we came together, and for every disagreement, we discussed until we agreed. And that is our separate set of consensus labels. And those consensus labels, that was a time-intensive process to get to them, but I think it results in very high-quality annotations. And those consensus labels are what I'll focus on in the rest of the talk. That's what we're going to use for classification. Okay, so that was the data set building. That was the hard part. Now we can move into more fun things. Not that that wasn't fun, but now our next step is to build a story detection system. Using the annotated data, the consensus labels, we evaluate a series of models for the story detection task, including a TF-IDF baseline, a fine-tuned Roberta model, and zero-shot and few-shot GPT-4 prompting. We ran these experiments about a year ago, so that's why. For document classification, given that we do have this small set, 500, also I meant to say, yeah, it's small, 500, because it is very hard and takes forever to annotate. But given that small set, what I'm showing are the results averaged over 5 cross-validation folds. So for document classification, we find that the best story detection performance actually came from the fine-tuned Roberta model, but GPT-4 zero-shot and few-shot prompts aren't so far behind. GPT-4 performed better than GPT 3.5, and chain of thought prompting provided high recall, but not consistently better performance overall, in line with other work on this kind of subjective task. For span annotation, we had better performance with the fine-tuned model than with GPT-4. In general, spans are harder, of course, than classifying entire documents, underscoring the importance of this story span detection task that we and some related work introduce. And we also find that our results generalize to other settings. Again, there's like very limited data available that we can really compare to outside of the data we've annotated, but we did make some comparisons. I can talk about that in the Q&A and show you some results if you want. All of that said, like, my takeaway when looking at this plot is that there's always more ways to prompt. There are many models that we didn't test, and there are newer models now that would likely perform better. My takeaway is that you can do reasonably well using a fine-tuned Roberta model or even using that SVM baseline. And if cost or access is an issue, so in this case, we wanted to actually use this classifier and run it over a giant data set of Reddit posts in this case. So I didn't want to pay OpenAI for every one of those queries. So this is good news that at least we're getting comparable performance with the Roberta baseline. Where does that fine-tuned Roberta model fail? Some error analysis. So stories that are misclassified as non-stories, sometimes those contain cognitive verbs like plan, decide, or notice, which we sometimes annotate as events using context to decide, but are maybe trickier. There are also cases where stories, again, are made up of hypothetical verbs. We annotated those as stories only when we considered those spans as strongly story-like. So this is where the subjective part of that annotation task comes in. But the occurrence of those is rare. And then there are also some very short stories, like one sentence or less, that the model didn't capture. And then non-stories that are misclassified as stories often contain general or repeating events. So I really like playing tennis. We're not going to annotate that as an event, but that's the type of thing that the model would latch onto. And also lots of pronouns, entities, concrete language, things that look like a story, but don't have the event sequence that we required. But works well enough on average, so we can move on then to the best part. Visualizations and data analysis. So we have this story detection system. Now we can use it on some data of interest to better understand where people tell stories and how they're using storytelling. To structure our results, we followed an open coding approach to categorize 500 popular subreddits into 33 categories. And we use those categories to structure the results I'm going to show you in the next slide. So each of these categories, like gaming or hobbies, mental health, can contain 1 to tens of subreddits. I'd like you to try the task yourself before I show you the results. So if we measure storytelling rates in communities that are belonging to these categories on Reddit, which do you think would contain more storytelling? Here are the results. The answer to the question I just posed to you is along the right, the purple bars. And what we see is that stories, addiction, animals, healthcare, I think, yeah, children is also up there. Those are the categories with the greatest amount of storytelling per subreddit on average. Some categories like professional advice have really wide variation in their storytelling rates. But in general, storytelling is more prevalent within communities focused on personal issues related to health and relationships. There is news and politics all the way at the bottom. I'm sorry, but a lot of people guessed that, and it makes complete sense. The thing is that I believe what's happening there is people don't go on those subreddits to narrate the news to each other. They go there to discuss the news. So of course, storytelling is important in news and politics. It's just not happening as often in those subreddits. And we can also map communities across multiple axes. So here is their storytelling rate, what we were just looking at, predicted by our story detection system. And then along the x-axis here, I'm showing the distinctiveness of the vocabulary in the stories told in that subreddit. So distinctiveness measures how similar a community's vocabulary is in comparison to a background vocabulary distribution. It's been used in prior work to map Reddit communities like this and also scholarly communities. And what we find is that categories of subreddits form interpretable clusters. Here I'm showing all the different subreddits mapped by their storytelling rate and their distinctiveness, and then colored by some of the larger categories. Yeah, so let me go here, which are a little easier to see. So it's the same figure, just pulling out some examples, like pulling out the corners of the plot that we were just looking at. So from more storytelling to less storytelling, and more generic story language used in the stories to more distinctive language used in the stories. So yeah, right up there in the top left, we see TIFU, Today I Effed Up. It's a subreddit dedicated to storytelling on all different kinds of topics, all the ways that you can mess up in a day. And with similar petty revenge, glitch in the matrix, these are also kind of generic storytelling subreddits. On the other hand, we have politics and other political subreddits with less storytelling and again, generic language. On the more distinctive side, with more storytelling, we have some healthcare topics and a specialized advice. And then with less storytelling, but very distinctive, we have a bunch of fandom communities. So at the top there, OIAF, A Song of Ice and Fire, Game of Thrones. So very less storytelling, but when there is storytelling happening, it's distinctive. And I think this kind of map can help, for example, researchers characterize their target communities and determine the appropriateness of building targeted story tools specific to their data, or whether you can adopt an off-the-shelf tool like ours. So overall, our contributions from this work include the Story Seeker Toolkit, data, codebook models, a first study that I've just shown you an overview of where people tell stories online. And then there's a ton more in the paper, including a case study of a specific community where storytelling is used as a rhetorical strategy across different topics. And also a span-based feature analysis of the story versus non-story texts that I mentioned earlier. Now that we have this story detection system, I think it opens up a lot of future work, some of which I and my colleagues have already started working on. So one is applying this story detection system to other contexts. Like right now, I'm really interested in TikTok. There's also a lot of open questions around the event annotations that we included in this task. I think there's a lot more that we could have dug into given infinite time, and that would be fun to dig into in the future. And then there also, again, the operationalization of storytelling that we use in this study is just one possible version of that. And we already have work following this project that's come out that we published last year, comparing our annotations, our researcher annotations to crowd workers' perceptions of storytelling. So if you're curious about that, you can check out that paper, which was at EMNLP last fall.
Thinking like, so do you have some sense of, for example, if one were to like take this forward and to somehow look into these areas of, let's say, what is a convincing story? Of course, there's the definition, like what do you mean by convincing, but do you have some sense in terms of like the linguistic patterns and the usage of like more of these adjectives or?
I'm sure there's a more elegant way to do this. Somewhere in here. Sorry. Yeah. We have some results in the paper. I'm not going to go into huge detail about this, but looking at the Change My View subreddit. So we have built in like annotations of which texts are more persuasive. We can look for which of those texts contain stories, rank them along the topics, and figure out maybe where storytelling is more or less persuasive. So it's like, yeah, lifestyle choices, maybe sharing your personal story will help persuade people. Yeah, really interesting. And like also the connection between storytelling, persuasion, misinformation on the internet, fascinating, something I'm thinking a lot about with the TikTok data that we're exploring now. Okay, so what we just saw was a bit more of that traditional downstream view. So we're still very focused on data. We had this data set of Reddit communities that we were interested in exploring and understanding, and we used these big models for that downstream purpose. Now we're gonna flip around and think a lot. We'll still talk some about classification and downstream tasks. We're also gonna think a little bit more about pre-training data and what's happening upstream. And to do that, we're gonna think about poetry. This was a paper published at EMNLP Findings last year, led by two of my collaborators at the University of Washington, Melanie Walsh and Anna Prius, both digital humanists, with degrees in the humanities and expertise in poetry and its popular reception. So Melanie noticed something interesting that now I can't unsee, which is that when journalists, social media users, marketers, and even LLM developers are publicly discussing the capabilities of big models, they like weirdly often talk about poetry. For example, Google named its first chatbot Bard, a traditional term for a poet and also the nickname of William Shakespeare. Anthropic, of course, has haiku, sonnet, and opus. Generated poetry was also one of the very first big model outputs to go viral on social media and remains popular there. This person saying, "I'm sorry, I simply cannot be cynical about a technology that can accomplish this," where this is write a biblical verse in the style of the King James Bible, explaining how to remove a peanut butter sandwich from a VCR. This is what impressed this person. And then Microsoft released an ad that featured its Bing chatbot writing poetry, as well as an instruction guide for how to write poems with Copilot, including a list of suggested forms to try. Why this fascination with poetry? Maybe because poetry is a signifier of human creativity and complexity, as well as a popular and culturally significant art form with a very long history. It's somehow a lightning rod for the marketing and popular imagination of large language model capabilities. And that's not necessarily new. I think as long as there's been natural language processing, there have been people trying to get computers to write poems, but this particular focus is maybe a little more intense. So in this study, in a nutshell, we wanted to poke at this notion that models know something about poetry. What do they actually know about poetry? What can they know about poetry? And going back to these data-centered questions and those upstream questions, what kind of poems were these models trained on? Where did that data come from? And we decided to use a single task, poetic form classification, as a lens into those questions. What do I mean by form classification? The task of form classification looks like this. I'll show you a poem's text and ask you to classify it into a form category, where a form is something like a genre based on features like rhyme, repetition, meter, topic, length, and visual form. So these are things in English language poetry, at least, like villanelle, sonnet, limerick. And it's important to note that traditionally form has been within poetics and literary studies, forms are fluid and sometimes overlapping, just like literary genres are overlapping. Forms are socially and historically constructed, and they've been the subject of heated debates, while at the same time having remarkable durability across time. This makes it really difficult and subjective to evaluate poetic form, but we're going to make a best attempt. There are a lot of forms, and we divide those forms into 3 categories. I won't go into all the details here, also because I am not a poetry expert. This is why I needed those collaborators. But broadly, there are 3 categories: fixed forms, formal elements, and unfixed forms. Again, these can overlap, and a single poem can belong to multiple categories. I want to establish for you that this perhaps is not an easy task, not even for humans and not even for human experts, people with PhDs in poetry studies. We ran a small study with human experts at one of the, I think at MLA, the literary conference, and I'll show you some examples to try yourself. So here's a relatively easier example. And I know not everyone may be as familiar with English poetic forms, but maybe it'll be familiar. Anyone know what form this poem is? Yeah, it's a sonnet, a Petrarchan or Italian sonnet, which is a little less common than a Shakespearean or English sonnet in English language. There are some other unusual things about it, but most experts, a little pie chart down there, most experts, not all, but most experts got it right. Where again, when I say the word right, this is all subjective, but and here is a harder example. Any idea what form? Oh, again, it's subjective, but. Okay, I'm being a little mean because I'm withholding information, which is the title and author, which would be very helpful for this particular poem. It's a haiku, arguably. I was giving a talk about this a month or so ago, and someone got in a big argument with me about whether this is actually a haiku. And again, I am not a poet, but I can relate to you what I do know about this particular poem. It doesn't have that traditional 5/7/5 haiku meter that is most well known. But as scholars like Richard Jean So and Hoyt Long, two prominent digital humanists, have said about haiku, the English haiku is both as recognizable as a 5/7/5 meter and as amorphous as a shared sensibility. If a reader is engaged with the history of haiku, they will recognize the reference to Busan in the title. Busan is an 18th century Japanese poet who is recognized as an early master of the haiku form. And then the reader would know that this poem has ties to haiku. However, if you encounter it without the title or without the author name, as our survey respondents did, it would be a lot harder to make that classification, which you can see in the pie chart. They were all over the place. So to emphasize, form is complicated, they're contextual and overlapping, and this task of form classification is hard even for experts. To set up the task, we gathered a bunch of poems from 3 sources. The Poetry Foundation, which is a nonprofit, and that runs Poetry Magazine and also hosts an online database of English language poetry with more than 47,000 poems. We also drew from the Academy of American Poets, another nonprofit that hosts the website poets.org with more than 10,000 poems. And then we also included a set of manually digitized poetry books. I won't talk as much about results on those books right now, but we talk about them more in the paper. The reason we wanted to include these was to try and include some poems that maybe had not been published on the internet yet, for reasons you may imagine or that we will get to later. Again, these were almost all English language poems and mostly focused on North American and European poets in this particular study. Overall, we curated from those sources about 4,000 poems, which have been tagged and categorized with their poetic form by human annotators on those websites. We don't have further knowledge about how that annotation took place or who did it, but it gives us some nice set of annotations that we can draw from for this project. Of those poems, we release 1.4 thousand of them, which are in the public domain. Those are available on our GitHub repo for this project. So if you want to play around with a data set of poems with their associated metadata, including form, it's available there. We don't make any in-copyright poems available. We then tested 6 modern large language models on this form classification task. And our goal here wasn't to build or find the perfect form classification system. If that were the case, we would test even more models. We would include all baselines like what I presented in the previous project. Here, we're trying to learn about the model, trying to learn about the source data set. We're not trying to build a best performing system. So we only tested 0-shot prompts with different amounts of information from each poem, such as the poem text, the poem's title and author, the first line of the poem and the last line of the poem, and then asked the model to tell us which form from the list the poem belonged to. We have so many results in the paper. There are pages and pages in the appendix of giant tables of results. I'll summarize here some of them. So when prompted with only the text of a poem, models perform better overall on the fixed poetic forms than on the unfixed forms or formal elements. In particular, classification performance for sonnets and haikus is particularly high. And there could be multiple reasons for this, including data imbalance, which I'll return to on the next slide. I'll talk more about sonnets then. The models generally struggle to identify forms based on repetition. although GPT-4 and GPT-4o did better at that more uncommon poetic category, especially with sestinas, villanelles, and pantoums. And then poetic forms based on topic were more difficult depending on the topic. There are some forms that are centered on more concrete subjects like death or art that are more easily recognized by these models, while poems about abstract ideas and styles are harder to classify. There are also far fewer forms in our data set that depend on visual features, but most models, understandably, do not perform as well on poems that are relying on the visual display of the poem as the feature that would tell you the form. Makes sense. Now let's think, I'm going to show you one result figure. Let's think about the model training data and memorization. Here I'm showing results when prompting with just the poem's title, the poem's author and title, just the first line of the poem, and just the last line of the poem. And what we see is that when prompted with only the author and title of a poem and not the text, so I give you just the author and title and ask you, is this a sonnet? Somehow the models achieve nearly as high or higher classification performance for certain categories, like sonnets. So for example, and most alarmingly, here are the sonnets. Why do these bars all look the same? That's not good. And there can be multiple reasons. So one, for sonnets, first of all, 40% of the sonnets in our data set include the word sonnet in the title of the poem. So that may explain part of the bar that includes the title, the light blue bar, the second bar from the left. But it doesn't explain everything. There could be other lexical patterns in both the title, perhaps even in the author's names, and in the poem text itself that indicates, there can be topical themes related to sonnets. Probably doesn't explain all of that though. And so this leads us to start thinking harder about memorization and what kind of poems are present in the pre-training data and how we might be able to figure that out and isolate that. So the last thing that I'm going to present is this exploration of memorization of poems in these pre-training data sets. We also want to go back to that original question about what models can know about poetry. Presumably they can only know about what they have seen. So what have they seen? This requires diving into the pre-training data. That data, of course, is usually hidden by companies for a variety of reasons, including both protecting their secret sauce and copyright issues. There's been a lot of attention on books data, but now we are trying to determine what kind of books have been used in pre-training data sets, but what about other cultural works like poems? So for example, there was this retrospective description of one of the major books data sets. And there was also this study of books memorization using a closed test to test closed models for what type of literary data they have seen. And there was this one study about poetry memorization, which we take inspiration from for our tests. We also relied on two open resources from the Allen Institute for AI, which is where I was working when starting this project. These are amazing resources. I really encourage you to play with them. First is DOLMA, which is a 3 trillion token English language corpus built from a diverse mixture of web content, scientific papers, code, public domain books, social media, and encyclopedic materials. It includes GitHub, Wikipedia, Wikibooks, Reddit, Semantic Scholar, Project Gutenberg, and Common Crawl texts, resulting in a very large pre-training data set that was designed with a lot of care to get as close as possible openly towards what a pre-training data set would look like for a big model. This is also the data set that was used for the training of the model OLMO, Open Language Model from AI2. And then this tool, What's in My Big Data, it's a nice toolkit that pairs with DOLMA to let you search for exact strings and return all matches along with their associated metadata, like where in DOLMA those matches are found, like which websites, what surrounding text, and other metadata. And what we find is that about half of the poems are not present in Dolma, where not even one line of the poem is detected. This does not, when we search for these exact matches of the lines within the Dolma data set using the What's in My Big Data package, that doesn't guarantee that those poems are not present in pre-training data for other industry models, but at least we know they're not present in Dolma. And what I'm showing here is that overall, if at least one line from a poem is detected, it's likely that you'll find all the lines from the poem somewhere in the Dolma data set. This figure shows the forms and the proportions of their associated poems that were detected in Dolma, categorized by the Dolma source along the y-axis. About 30% of our poems are found in the Common Crawl data included in Dolma, with the C4 data set close behind. There are also some sources like Project Gutenberg. So like this, the third here, where Gutenberg contains significant percentages of certain of the forms like ballads and couplets, but not other forms. So depending on which mixture of sources models are trained on, they may have different representation for different poetic forms. There's also a lot of fun stuff you can dig into, just kind of highlighting some of the fun things you can do with What's in My Big Data, pulling out the specific web domains where matches are found. So GitHub is actually the place where we found the most poetry matches. There's a lot more to explore, including thinking about where poems appear online, their reception, how they're spread and shared, that you could also dig into using these tools. But now that's searching directly for string matches within the Dolma data set. Now we'll just try to compare that with the closed models. And the best way we have to do that is to try and design some kind of prompts to elicit information that would let us know that the model has seen that poem before. We replicate tests from the study I mentioned before by prompting to produce the next 5 lines of a poem, given the title, author, and first line of a poem. And what we find are that 42% of the poems are likely memorized by GPT-4. And of those, 36% were also present in Dolma. So that means 60% that were likely memorized by GPT-4 are not in the Dolma data set, which is not surprising. We know that they're using copyright data to train these models, but it's very likely that they're using copyright data to train these models. But yeah, it seems that there is more poetry data available to those closed models like GPT-4 than is available in open resources like Dolma. Going back to form classification, then we can then categorize our poems by likely memorized or likely not memorized. I think there's a lot more that could be done here, including more formal statistical experiments to test for correlations between memorization and performance. But just kind of eyeballing it, it does look like the columns on the right have lower performance sometimes than the columns on the left, meaning that memorized poems are easier to classify into specific forms. Just want to briefly talk about some implications of this study and then kind of larger takeaways from both of these studies. So from this study, implications for poetry researchers, readers, and digitized collections. First, these model evaluations, I think, can offer scholars insight into the legibility and durability of different poetic forms, as well as how forms relate to each other. And there are also implications around tools and data sets like Dolma that allow us to measure the circulation and reception of poems on the internet. Where poems appear in training data is often where they appear online. So if you're interested in the reception of these kind of cultural works, this could be a way to approach those questions. And then for NLP researchers, first, collaborations with humanities scholars can enrich studies of model capabilities and pre-training data sampling. We should collaborate together. The evaluation of systems to detect rhyme, meter, topic, repetition is unique from the detection of prose genres, which rely mostly on topic. So it's an interesting task to work on. And finally, designing benchmarks is hard. It's always hard, but it's especially hard when you have problems like memorization, which is an uneven issue that's really difficult to quantify and document. We need more open resources for auditing pre-training data sets. And then I'll skip, and then from both of these studies, AI and the humanities can work together. We should work together. We should work together more. We need deep collaborations between humanists and computer scientists. We need people working both downstream and upstream. And my plea is that culture is about much more than cultural value alignment and nationalities. There are important problems and possibilities that are brought by these big models that go far beyond bias measurement, which is important, but there are all these other cultural topics and questions like poetry and storytelling that we can also work together to explore. That is all. I can take some questions for a few minutes.